You've probably heard of the Skidmore, Owings Merrill-designed Burj Khalifa Tower, formerly known as the Burj Dubai, unless you've been living under a rock, which is quite un-ninja-like. In addition to holding the distinction of the world's highest skyscraper, the Burj Khalifa is also the tallest structure ever constructed by humans, rising 828 meters, 2,717 feet, to the top of its spire. But do you know the story of the man behind this Magnum Opus? In this video, we will be providing you with all the insights into the man behind Burj Khalifa. But before that, make sure to subscribe to the channel and hit the bell icon for such updates. Let's find out the man behind Burj Khalifa and his vision. The Burj Khalifa in Dubai, which is the highest man-made tower in the world, was built by Bill Baker. He discusses the engineering difficulties associated with really tall buildings here. It's merely a project, when Bill F. Baker discusses his team's contribution to the Burj Khalifa Tower, which opened in 2010 and continues to be the world's tallest man-made structure at 829 meters. It almost sounds as if he is underestimating their work. I'm not particularly interested in the height record per se. In fact, I anticipate the record being shattered soon. When you want to make a jump upward, it's fascinating because you have to create completely new systems. Upscaling the structures from lower buildings is just not doable. Bill Baker designed the distinctive hexagonal core structure that supports the world record while serving as principal engineer at the architecture and engineering firm Skidmore, Owings Merrill, SOM. See the explanation below. In addition to its actual height record, the Burj Khalifa also boasts several other records, including the title of having the highest occupied floor in the world, 584 meters, and it has won numerous awards. Therefore, to put it bluntly, the initiative has not lacked media attention globally. However, it should be noted that Bill Baker and his crew got some of their ideas from Denmark. We at SOM are interested in the topology optimization work being done at DTU. Engineers and architects are equally important. The goal of topology optimization is to distribute a structure's material in the best possible way. The vast majority of structures in our daily lives are oversized in the sense that less material may be used while still achieving the necessary load-bearing capacity. Avoiding unneeded weight is essential when trying to push the boundaries of what is feasible, such as when building the tallest structure in the world. In other words, one of the key factors that made it possible to construct the Burj Khalifa was applied topology optimization. Collaboration between the engineering team led by Bill Baker and the SOM team of architects under the direction of Adrian Smith has been another prerequisite. Concerning really high-rise buildings, the conventional division of labor, where the architect first creates the drawing and the engineer must then come up with a technical solution, is absurd. The engineer must be involved from the beginning, which is also how we always operate at SOM. According to Bill Baker, I think this is one of the key reasons we've been invited to work on so many projects in the region. Selected after 2 intensive weeks. Following a lengthy idea competition that lasted just 2 weeks, the customer, Emaar Properties, chose SOM to complete the project. Here, Bill Baker proposed a plan that drew inspiration from a different SOM undertaking. Understanding the essentially contemporary approach to developing really tall buildings is necessary to comprehend Baker's concept. SOM engineer Fazlur Rahman Khan, who died in 1982, introduced the bundled tube idea in 1963. The Willis Tower in Chicago is the most well-known instance. For the following 25 years, the building, also known as the Sears Tower, which was finished in 1973, was the highest structure in the world at 442 meters. 9 tubes of various lengths make up the structure. All subsequent extremely tall structures have utilized Khan's fundamental concept of dispersing the static forces, also known as loads, by professionals, that the structure must bear on multiple separate tubes coupled together. However, there have been several important advancements made to the theory over time. At one point, it appeared that if the building's height were lowered, the sole project would be allowed. We altered the drawings and changed the building's 130 floors to 92 floors. Bill Baker remembers, but in actuality, I was certain that the design could have supported a substantially taller construction. I, therefore, viewed the new project in Dubai as a chance to execute the concept. Surprise in the wind tunnel. The sole concept, however, was not prepared for the higher height. To my amazement, it entirely failed when we exposed the enlarged core design to the wind speeds that Burj Khalifa had to withstand in a wind tunnel. Bill Baker says, today, though, he views this seeming setback as a blessing. We probably would have attempted to modify the design if we had been really near to the objective. But now we had to think of something new. This brought us to the Burj Khalifa's buttressed core. The buttressed core and topology optimization together have greatly reduced the number of materials needed for the Burj Khalifa. A conventional design, such as that of the Empire State Building, the standard skyscraper, would have required twice as much steel and significantly more concrete. Burj Khalifa's construction was made possible thanks to its minimal material usage. The building's tripartite structure, which is hexagonal, has demonstrated an excellent ability to withstand vertical loads brought on by the structure's own weight. It also stops twisting at the same time. We also discovered that by situating the building in relation to the predominant wind direction at the site, we would be able to drastically lower the loads. The forces in the wind tunnel were significantly decreased by rotating the building 60 degrees about the original concept, according to Bill Baker. A building is like an instrument. Fortunately, the outcomes of the wind tunnel have been confirmed by reality. A 244-meter spire makes up the structure's summit. Despite its enormous height and powerful wind, the spire's highest point only sways a maximum of 1.5 meters. Bill Baker claims that just a portion of the cause can be attributed to the design's fundamental robustness. The head engineer stands up and makes his tie swing in order to accentuate his point. The coffee cup in front of him is then hit. A clothing booth is then set up in the conference room. Everything naturally oscillates. This also holds true for buildings. In order to control the natural oscillation, the design has been adjusted. Actually, this is extremely similar to a musician tuning his instrument. However, this project went off without a hitch. The contractor frequently encounters issues with common low-rise buildings that don't pose a serious threat but do call for design changes. Then one day you realize the once minor issues have ballooned into major issues. Extreme high-rise buildings are an exception to this rule. Here, you deal with issues as soon as you see them because you understand how terrible they could be. Low pay. It should come as no surprise that workers received incredibly meager wages in exchange for risking their lives to construct the $1.50 billion tower. The Burj was constructed by about 10,000 to 12,000 workers. Most of them were low-income migrants from South Asia. A Human Rights Watch study found that some workers in the United Arab Emirates reported earning less than $10 USD a day since there are no laws limiting minimum wages there. Employers frequently seize employees' passports in Dubai in order to prevent them from leaving the country before their task is done. Emaar Properties recently asserted that 90% of the building had been sold, but it is unclear how much of it would be occupied. A representative declined to answer when asked if the economic downturn has caused purchasers to back out of negotiations at Burj. According to rates for apartments in Burj Khalifa, rents in Dubai have decreased by 30 to 60% on average during the past 2 years. Apartment prices in the skyscraper have decreased to less than half of the 10,000 dirhams, $2,700 per square foot that they peaked at in 2008, according to Bloomberg News. Fascinating facts. At the height of the tower's design, 100 staff members from SOM's Chicago office and others from Dubai were engaged in the project. The Sydney Morning Herald reports that the skyscraper is made of 330,000 cubic meters, 11.6 million cubic feet, of concrete, which, to put it in context, weighs as much as 100,000 elephants, as well as 39,000 tons, 86,000 pounds, of steel rebar. The tower's top can be seen from 95 km, 60 miles, away and sways an estimated 1.5 meters or the height of the typical person. That's it guys for now. A very tall skyscraper in the recently constructed downtown Dubai, the Burj Khalifa redefines what is possible in design and engineering. It is without a doubt the world's tallest structure. The structure was designed to serve a modern community while drawing inspiration from contemporary architecture. All thanks to Bill Baker's inspiration and idea. If you like the video, make sure to subscribe to the channel and hit the bell icon. Leave a like, share with your friends and families, and pin down your thoughts in the comment section below.